Hey guys, Kevin here, and welcome back to the course. So in this segment, we are gonna clean our data, and for this we aren't taking some ready-made data. We aren't gonna do that. I just went into Excel and I created this small data set with 10 entries over here. So it's name, age, their weight, and the gender. Right. So here I've just taken random names, which do happen to coincide with Marvel characters. Yeah, and I've got their age over here. I've got their weight over here, and I've also got their gender over here. So now we are going to be working with this data set. So obviously what you can do is you can just head on to your Excel, pause this video, create a similar data set, write your friends' names or whatever you want to do, and create a similar data set, right? And we're going to move ahead, right? So I'm just going to head to the file section. I'm going to go here, I'm going to click upload, and I'm going to click data. That's how I saved it, data.xlsx, right? And then I'm gonna import pandas, import numpy. I hope you have seen the previous video. And let's import them, and then let's read our Excel file and store it in the variable df. Okay. Now, first of all, as you can see in the data set, we have got some missing values, right? We don't know what is Scott's age, we don't know what's Wanda's age, we don't know what's Steve's weight, and we don't know what's Wanda's weight is, alright? So that's a missing value which will hinder with our further operations that we perform on the data. So usually there are multiple approaches to this. First approach is that we just eliminate the entire data entry whichever has a missing value. But obviously you might think that that hinders our entire prediction that we make in the future, because let's say I've got 10 data sets over here. If I were to delete any two of them, because I have got three data sets over here, three data entries, Steve, Scott, and Wanda. And if I were to delete them, I'll lack some data. Out of the 10 data entries that I have, I'll now only have 7 data, and it's just for like 10. Let's say I have data sets which are like 5,000 which have 5,000 entries, 5,000 rows, and inside them may, like, let's say 30-40% of them have one missing value or the other. Eliminating them would make our life difficult. So that's not something that you would do. Second thing that you could do is you could take the mean of the entire column, and you could place that mean over there in the empty values. So let's say the mean of all the ages of the people, excluding Scott and Wanda, is, let's say, some number X. So then that number X is placed over here and over here, so the data remains more or less similar. Same is done for weight. So that's mean. Another thing you could do is that you can put the median over there. So whatever the median you find out of the entire column, that is replaced over here. Third method is you could take the most frequent value and then put it over here. So let's say over here I think I got 65 and another 65 over here. I got 265. I think that I also got 275 and so on. So whatever is the most frequent value, the program will decide it, and it will replace these missing values with that value. So even that can be done. And also in some cases you wanna just put some values that you wanna customize on your own. You could do that as well. So let's first check this data set. We could spot that there are missing values, but sometimes, as I said, have 5k entries. It's difficult to spot them. So what you can do is there's this command called dataframe.isNull, and then it does the sum. So it does the sum of all the null values in each column and tells you how many null values are occurring in each column. So let's run that. And we get over here that name has no null values. However, age and weight have two null values each, and gender has no null values. Okay, so that's pretty modern stuff. You should do this on all the data sets to check which columns have missing data. We could also do that with the previous data set we used with the Marvel characters one. That can be performed on that as well. Now we're going to be using the simple imputer. Alright, now simple imputer is a command that is available on scikit-learn, and we have imported it from scikit-learn over here. So if you want to read more about the simple imputer, you can just go and write simple imputer. Alright, and you'll get the documentation where I've seen it, I've visited it today itself, and I'll just click on it. and this is the documentation of scikit-learn, right? So everything related to this function has been mentioned over here, all the parameters, everything. So you can obviously read it over here, what it does and what it doesn't. I'll explain it to you obviously. So what simple imputer does is that whatever missing values that you have, it will just, whatever you ask it to do. If you ask it to, replace all the missing values with a mean, or you ask it to replace all the missing values with a median, whatever you want to do, it will perform that action for you, right? So first you import simple imputer from scikit-learn. Then you say that simple imputer equals to missing values and numpy.nan. Numpy.nan function will give you the location of all the missing values, and then it will ask you for the strategy. And the strategy is over here. We are doing mean. I'll also show it to you for median and for for most frequent and for constant, right? Once that is done, you ask the imputer to fit. Alright, so what fit does is it fits your data set inside the inside the imputer. So it tells the imputer that this is the location where the missing values are there, and there, let's see, in our entire data set over here, we have the second column and the third column, right? So that's index 1 and index 2. So it will tell the imputer that the missing values are present in the column with index 1 and index 2, and over there, wherever you find the missing values, you have to replace it with the mean. Alright, so that's what it does. It fits the data set with ilog. So ilog function was here you have all the rows, and here you have the selected columns, that is 1, 2. Alright, so it's 1, 2, 3 excluding 3, so that's 1 and 2. So first and second column over here, and then what we just did was we did the transformation on it, and then we were like data frame.ilog, these two columns, replace them with the imputed columns. So let's just run this, and we get a green tick over here, so that means our entire processing has been done. So let's just print it, and now you can see over here that look, Scott had no age. Now over here, Scott has an age of 66.375, and as Wanda also has an age of 66.375. Alright, this is just a proof of concept. Obviously, this isn't correct, but like when you're working with large data sets, and the factors are not something like age, they are something which can, where if you put the mean of the entire column, if your work can be done, you can use mean over here. Similarly for weight, Steve was missing his weight and Wanda was missing her weight. So Steve has a weight of 75.625 and Wanda has a weight of 75.625. Alright, so all the null values were replaced with the mean value. And we can also run this now and check, and we can see that there are no null values anymore. Right, now let's say you wanna have a look at the median. So what I'll do is I'll just copy this entire code. I'll create a new code over here. I'll paste it over here. I will also re-import our data frame, right? So that it gets reset. The value of df is reset, and let's just run this. And let's add another column to this, and another code to this. Print df. Let's run this, and you will see a difference over here that. Okay, this was me, right? Let's change it to median, right? And let's run that. Yeah. So now Scott has a age of 36.5. Wanda has an age of 36.5. Earlier they had 66.375, and here it's just the median over here. So Scott and Wanda got the median age, and similarly they got the median weight as well, right? 80 and 75. There is another thing called, I think, most frequent, if I'm not wrong. Yeah. If I do most frequent over here, and if I run that, Scott is now 19, Wanda is also 19, and over here in the weight, Steve is 65 kgs, and also is Wanda 65 kgs. That's the most frequent value that is occurring. In age, we didn't have any frequent values, so it just took the first value and printed it. So that is how it works. If I were to change, if even Thor would have an age of 19, then everyone would be 19 or something like that, right? We also have over here constant. So let me just show constant to you. And in the case of constant, if I were to run this by itself, it will do nothing. It will just put a zero over here. But that's not something that we want. So we'll also mention a thing called fill values. Alright, fill value. So fill underscore value. You can also see that collab will also give us all the documentation over here, right by our side that was given over here. So that's pretty appropriate. And fill value with let's say if I want the value to be 50. All right, let's run that. And now you can see that Scott has a 50 age, Wanda is 50 years old, Wanda's weight is 50, and Steve's weight is 50. Alright. Obviously, you could do this multiple times for like age separately, for weight separately. You could, instead of fitting it for 1, 2, 3, you can just copy this twice. Just keep one column over here. In the second case, keep the second column over there and put your custom weight value as well. So yeah, that's how all of the different strategies for computer work. So now let's have a look at encoding data, right? So what basically encoding is that inside your data set, let's take an example. Let's say there are certain factors given to you. Let's say factors on a house, right? Whether the house has, how much area, square feet area the house has, how many windows does the house has, does the house have a garage, does the house have a backyard, does the house have, let's say 3 floors or 4 floors. So you've got certain factors, and according to that, your price of house is determined. Okay, so you've got a data set, you've got 5 features that I just named, and then the last column is the price of the house. Now let's say I want to create a model where once this data set has been loaded in, I go to some other place, I enter all the 5 features, area, backyard, garage, whatever it is. I enter the 5 features, and then I get an approximate price of it that has been predicted by our model, right? So for doing that, are in this case, our independent variables are those 5 features on which the price of house has been determined, and these are the independent variables, I repeat, and the one dependent variable, that is price of house, is dependent on these 5 features. That's why the house price, or our target variable, is the dependent variable, and the 5 factors are our independent variables. So now what happens is, assume this, when in some cases, like over here you have got gender. Gender is a independent variable. If we want to encode that, we will use something known as one hot encoder. Now what one hot encoder will do is that, let's say I've got male and female over here. Now dealing with male and female in terms of strings is difficult. So what we'll do is, we are saying that it's a categorical data, right? It's either male or it's female. So what we will do is, you will create 2 columns, 0, 1, 0, 1. 0 or 1 can be the only values over there, and the gender column will be replaced by these 2 columns of zeros and ones, and based on their values, computer will understand that this guy's gender is this. So let's say male stands for 0, 1. So whenever you've got 0, 1 over there, it means that the gender of the guy, or gender of the data of the person, is male. And if let's say you've got 1, 0, the gender of that character is female. Alright. So we'll be using one hot encoder. So again, from scikit-learn, we'll import column transformer. Alright, I'll just this over there. So I'll explain what column transformer is to you. Let's just copy this. Let's go over here to scikit-learn. And this is how you learn coding, because not everything can be taught to you by some tutorial. So this is how I learned. I learned it from the documentation as well. So what column transformer does is that it enables the computer to have the power to change the value of the column, as I said, from male or female to a new column in the form of zeros and ones, right? So that's how you can transform columns, and then we are going to be using one hot encoder. Now what one hot encoder does is, as I explained, it will create 2 columns, 0, 1, 0, 1. So let's just have a look at it in action. So we create CT over here, right, a variable, and then we say that CT is the column transformer, and over here we define transformers. So if you have a look at it here, transformers is a list of tuples, alright. So as I said, for male female you'll have 0, 1 and 1, 0, just assuming them. So you will have the name of whatever you are performing. So we are performing one hot encoder, So we'll put the name as encoder. We'll use the name of the transformer, that is one hot encoder, and then a function brackets over there, and then the columns that we want to transform. And what will happen is one hot encoder will do its magic. We want it to be applied on the column with index 3, so that's our fourth column, gender, and you have another field called remainder. Now what remainder does is that over here we selected column 3, right? So if you were not to mention this entire thing, if you didn't mention this over here, what will happen is that all the columns other than column with index 3 would be deleted from your data set. We don't want that, right? So that's why what we'll do is we'll say that the remaining columns should be just passed, and then we fit our data frame according to CT, and let's run that. So we get a green tick, and let's print it. And what we get over here is instead of male you get 0 1, and instead of female you get 1 0. So you can see that Shuri, Natasha and Wanda were females, so you got 1 0 1 0 1 0, and other all were men, so they got 0 1 0 1 0. Alright, pretty simple. So that's how your one hot encoder works. And yeah, if you want to have a look at drop, I've also done that. So I created another data frame called FD. I read the data set again, and then I applied the same encoder where I kept the remainder as drop. And when I printed FD, what we received was all the other columns like Tony 35 and 75 got deleted. Right, so that's how your remainder entity it works inside the column transformer. Alright. Now for independent variables, so out of the six that we had, let's say the house price. Uh, in this example over here, we will assume the column with index 3, that is our weight, to be our target variable. Alright. So we'll assume that weight is our target. We have to predict weights over here. Uh, so what we will do is we'll split our entire data set into X and Y. X will contain all the features and Y will contain our target. Alright, so Y will have the column of our weight and X will have the remaining three columns, that is name, age and gender. Alright, so X equals to df dot ilog function, we saw it earlier in pandas, ilog function, and it will contain all the rows and 0 1 and third column, and Y will contain just the column with index 2. Right, so let's print that. uh, so let's bring back df over here and let's run this. Okay, uh, so yeah, df was earlier a numpy array, and it had been x and I had turned into a numpy array, so that was a bit complicated. So we just redefined df, our data frame, and then we asked x to use the ilog function, that is all the rows, the columns with index 0 1 and 3. So that's your you got name, age and gender, and then weight is the column with index 2, and that is your target data frame, which is y. So print x, print y. So we got Tony, we got his age and we got his gender, and then Tony's weight was 75, and obviously we got our missing value over here. So I think what we need to do is we'll need to run this function. So let's do one thing. Let's run this. Let's run this. Let's run this. And yeah, so now our missing values have gone away. Now let's ignore all the other things that we just performed on this, and let's run this. Okay, yeah, we did a mistake, so my bad. So let's just run this. Let's run this. Let's run this, and now we can see that our missing values have disappeared. And let's keep our df the way it is. Let's run this. And now x has got its mean values over here. Alright, the missing values have been replaced with the mean values. Alright, so our missing values have been removed. And then now we used one hot encoder for dependent variables. For independent variables, we'll use label encoder. What label encoder will do is, instead of this having varied like 75, 65, 90, it's difficult to deal with this, right? So it will just give it 0, 1, 2, 3, 4, 5, 6. Alright, and that's how label encoders work. So we'll transform y over here. So let's do that. receive a green tick, and let's move forward. And now y is 0, 1, 2, 3, 4, 5, 6. How it happened was the least value, I believe, is 60. So 60 was given 0. Then we got 65, and 65 comes twice. So wherever we had 65, got the value 1 and 1. Then we had 75, which got the value 2. We had 75 again, so that got the value 2. Then we had 75.625 and 75.625, so those got the value 3. So now what happened was each target variable got converted to 2, 1, 5, 3, 6, 4, which just made our lives 10 times easier. Alright, instead of dealing with such numbers, these are 1, 2, 3, 4, 5, and according to that, prediction is easy. So that's encoding is over with. Now obviously the example that I've taken over here is just so that you understand it. Sometimes you may not need to encode certain things, but because we need to save time and we need to understand all the concepts, that's why I've used such a vague example. Sometimes you might not need to use all of the above. Alright, sometimes you might not need to encode the independent variable. Sometimes you might just need to encode the dependent variables or whatever it is. Uh, just keep that in mind. We are just learning over here. Okay, so now let's have a look at splitting the data set. Alright, so how this works basically is that in our data set, what we did was our target variable was our weight, right? So let me just paste weight over here, and I would give some value over here as well to prevent confusion. Alright, 90, and one die would be, let's say, 25, spot will be 34. Right, let's cut this, let's leave it over here. Right, so let's say this is our entire data set. Okay, now how our model basically works is that it will have two different data sets. All right, so one will be the testing data set, one will be the testing data set, uh, and the other will be the training data set. Alright, so what training and testing is, you might ask. When we are making our model, when we are training our model, we will feed it some values that whenever, let's say, the age was 35 and the gender was male, the weight was found out to be 75. When the age was 19, the gender was male, the weight was found out to be 65, and so on. So we, trained our model. We told him that whenever these factors had these values, the corresponding output value was this. So now get a hang of it, and then it will tell it that now tell me what should be the output when I give the input as age as 24 and gender as female. Alright. So the machine knows that whenever this is the input, you should give me the output as this. So now whenever I give this as the input, what would the output be? So it will give some value. Let's say instead of 60, it will give it 55. Let's say instead of 65, it will give something like 50. Let's say in the 90, it will give you 87. 75, it will give you 70. Alright, so it will predict the values according to the learning, according to the training data set. And then obviously you've got the corresponding outputs, real outputs for what this predicted. It will check how different these values are, and according to that it will adapt. So you obviously always need a training data set and a testing data set. Now usually in some of the data sets you have two different files given to you, one as training and one as testing, but sometimes it isn't given. So in such cases you will need to split your existing data set into training and testing. So for that, we again have the train test split module from scikit-learn. And what we do is we write the name of our datasets. So x train, x test, y train, y test, and then train test split, x comma y will be the input for it. And the test size is 0.2. Alright. Over here we had 10 entries, we had 10 names. 0.2%, 0.2, that is 20% of these values will be considered for testing, and the remaining 80% will be used for training, and random state 1 which will randomly pick up values. So let's run that, and let's print all of these new variables that we have. And what you can see over here is that x underscore train gave us the name or the entries of these 8 people, alright? That is Shuri, Thor, Tony, Steve, Peter, Natasha, Wanda, and Scott, alright? So these 8 names were given for the training data, for the training set. For the testing set, Bruce and Loki were given. So now what will happen is the machine will train on this data. So it will know that whenever I receive a 24-year-old female, her weight should be, according to the encoding that we did previously, 0. So whatever 0 leads to, I think it leads to 60, alright? So whatever that is, it should fetch me 0. Whenever the weight of a male is 150, it should be 6, and so on. And then after it has been trained on these 8 entries, it will be tested on these 2 entries. So 38-year-old male and 135-year-old male would be given to it, and it will predict certain values, and those values will be compared with 5 and 2, and whatever turns out to be, the machine will undergo that test. So that's how you can work when you have not been given a separate training and testing data set. Obviously, when you have been given 2 separate files, you will just obviously you will split them into X and Y as we did over here, right? So you'll have 2 datasets, df underscore test, df underscore train. So from that you could split X and Y, X train and Y train. So now let's move on to feature scaling. All right. Now when is feature scaling used? Uh, let's say you've got multiple. Let's say you've got a specific feature like we had age over here. All right. So now when we had age, the ages are very varied. So like if you have a look over here, we had Loki who was 135 years old, and then we had Peter who was 19 years old. We had Thor who was 150-year-old. So such things make it a bit difficult for us to work. So what we do is we rescale these values. So whatever value that Thor has, that is 150 kg, it will be rescaled. So it will be divided by, it will we'll perform an operation on all of these values so that we receive values which are more comparable and easier to work with. Now you might have done this in your math. I think usually it's in first year or second year math in statistics and probability. So what you do is you try to make the mean of the scaled data. So whenever whatever value I change from 150 to, let's say 150, we have got 150 kg as the weight of thought, right? I'll rescale it to, let's say, let's assume a number as 1.5. I'll rescale 150 to 1.5, and I'll make it so that the mean of all the data set should be 0. So when I add all of them and divide them, it should cancel out each other. The addition of all of them should be 0, and the standard deviation should be 1. Right? So what you do is Z is your new scaled value, X is your original value, so that's 150 in our case. So 150 minus the current mean divided by the current standard deviation will give you the new value. Alright, so that's simple math. I'll repeat. Thor's weight was 150. 150 minus current mean divided by the current standard deviation will give you the new value. And when you get the new value of all of these entries, all of these features, when you get the new scaled values, when you take out the mean of these new values, it will be 0 and the standard deviation will be 1. Alright. So for that, we'll use a standard scaler available on scikit-learn. Alright. And again, we'll use the column transformer for this. We have already imported the column transformer. Over here, instead of encoder, we'll call it scaler. We'll use the standard scaler over here, and we'll be just be selecting column number 1. Sorry, column with the index number 1. So over here it was the second column, that was Shuri age, alright, age 24. So remainder would be passed through. Remainder should remain. It should just be passed away. It should not be transformed. So X train cd.fit transform, X test cd.transform, transform, and X test and X train. So let's run that. We receive a green tick. So let's move forward. Let's print them. And here you can see that now Thor has 2.099 as his weight, and Loki has it as 1.744, and so on. And when you would add all of these values, they would and divide them by 10. The output that you receive, the mean that you receive will be 0, and the standard deviation of these will be 1. Right? So that's just how scaling works. So before we move further ahead, there is one last thing about preprocessing, which is called feature selection, right? So now for this to work, we have used the house price prediction data set, which is available on Kaggle. So I'll just show it to you. It's available on Kaggle. You can download from here from the link given over here, and it has a data. It has the data over here. So we basically have 18 columns. All right, let me just show them to you. Select all, and we have got the date over here. We got the price. We got the bedrooms, number of bedrooms, number of bathrooms, square foot living area, lot area, floors, how many floors are there, waterfront view, condition, square feet above, all of those 18 columns, alright. And using this, uh, we need to create a model which will predict the price of our house, alright. So you will be given with the number of bedrooms, number of bathrooms, all of these data, and then you need to predict what price it is. Now the machine learning model, obviously we have got all of this data, right? It's a lot, like in thousands or something. So we'll use 80% of the data because we don't have a testing and training data set. So first what we'll do is we'll split the data into 80% training, 20% testing, and according to that we'll be building a model. So now we need to pre-process it. So I've already done the pre-processing. So I've downloaded it, I've put it over here as the house price CSV, and we are gonna go through each code cell. So first we imported pandas and we imported numpy, right? Let me just remove all the outputs. Alright, yeah. So first we imported pandas and numpy and we read our house price CSV. Alright. Next we will have a look at our data set. So it gives us the date, price, bedrooms, bathrooms, all of it. Now you might notice one thing, that country for all of them is USA. Right? If you have a look over here, for all of them the country is USA. It doesn't change. So that is something which will not make any difference in our data set. So if the country column isn't there, there will be no change, right? Because our entire data set is based in USA, so that won't make a difference. Same applies to street. Everyone has a different address, so even that won't make a difference while predicting our output. Same applies to date. All of them are based in 2014, so even date won't play a major role in the price prediction. Uh, so let's move on, right? So first we will be checking for null values, alright. So we can see there are no null values over here, alright. Everything is zero. Now, as I said, country, state, street, state zip. Again, the zip code won't make a difference because obviously we are including something, like we are including the city, right? So in the zip code won't make a difference in it. So we'll delete the zip code as well. We'll delete the country because it's USA. Street is, everyone has a different street almost. Some of them will have a common street, but like that's not relevant. And the date. So let's just print that, and let's remove that and print it. So now our data set is a bit smaller, right, compared to earlier. We don't have country, street, size, and date columns. Uh, Next, we're going to split it into x and y, so our target and our features. So x will be our features, so we'll use a drop function and we'll drop the column, price column, and in y we'll use the ilog function to just mention the price column in it. So let's do that. As you can see, X has been printed over here. X is all of our 13 columns and Y has just one column, which is the price of it. Alright. Now, oh, okay. We might have made a mistake over here. Yeah, we need it to be 0. Oh, it should be 0. It should be 0 according to the new data set where we remove date. It should be 0. Yeah. So it is 3.13 raised to power 5. Yeah, 3.13 raised to power 5. That's accurate. Alright, so we got x and y over here. Now, what I want to do is, you can see over here that our cities, they are Seattle, Kent, alright, they're cities in the US. Now, obviously, we need to encode this. Now, one hot encoder will become a bit complex for this. So, what we'll do is we'll use label encoding, as we saw above. So, in label encoding, for that, I'll create a new data set with just one column k. So let me just print K, and it will have Shoreline, Seattle, all the cities over there. And then we are gonna import the label encoder as we saw about. So we are just gonna put that on K. So we got K over here in terms of numbers. So each city has been assigned a number, and then like let's see, Seattle is the second entry over here, and the second last entry is Seattle. We got 35 and 35. Seattle has been assigned the number 35, and that's how our label encoder has worked. Now we'll take the city column in our X and we'll replace it with K. Pretty simple stuff. And then we print X. You can see over here that city is now encoded. Alright. So let's check. We have got 3 over here for 4596 and 3. Index number 4596 and 3 should be the same cities. 4596 is this and 3 is also the same city. So that's the proof that encoding has worked. Now, obviously, as I said earlier, we don't have a testing and training different data set, so we're just gonna split them. 0.2 would be our split size, so 80% of the data set would be used for training, 20% for testing. Let's run that. Okay, so that has been done successfully. Now, uh, now we are gonna now is the place where the magic comes in. So there is this thing called mutual info regression. So what mutual information does is it creates a score between two random variables, and that score is obviously non-negative. And in what that score implies is it tells us the dependency between the two variables. All right. So in our case, the fixed variable will be the price, house price, and then for each feature, we will check how dependent house price is on that feature, and according to that, we will come to a conclusion that house price depends most on this feature, and then this feature, then this feature, and so on. And it will give us scores from 0 till whatever it feels like, till the amount of similarity exists. So let's just import that from scikit-learn. Again, if you want to have a look at this, just copy this, and paste it over here. And here's the proper scikit-learn documentation. You can read it. Right now, I'm just gonna skim through it so that you can just go through the part that is important. Now we'll be defining a function which will do the work for us. So we'll create a variable called mi scores, mutual information scores. We'll use a mutual for regression, and we'll put x, y. We'll also set discrete features to false. So over here you can have a look. Discrete features is that it determines whether to consider all features as discrete or continuous. All right. Now we are gonna treat them. We're gonna put discrete features as false. Next, we have got mi scores. We are going to index them in columns, and then we're going to sort them in a descending order, and then we're going to return the mi scores, right? And we are then going to call the function. So the function I will define over here, we're going to give x train and y train as the input, and let's just run that. Okay. So now, according to that, we have got a variable called mi scores. I could even print that for you. Print mi scores, and I'll probably need to run all of these again. Give me a minute. Yeah, so we have got score for each of the uh, feature over here. So what we are gonna do basically is we can also determine it from here, but who doesn't like plotting graphs? So let's just run matplotlib. Right, you can go through matplotlib documentation as well. It's available on the net, and we're just gonna plot a bar chart over here. So we're gonna use mi scores, and let's just run that. Okay, so what we have over here is that all of these features are the major ones on which our house price is being determined on, and according to that, we can say that waterfront has very less impact on the house price. So we can exclude waterfront, we can exclude condition, we can exclude year renovated, and it depends on us how accurate we want the model to be. So I'm just gonna keep a cutoff of 0.1. So anything which is below 0.1, that is below 10%, we'll just remove that. We'll just not include that. So let's remove everything apart from all of these four columns. So let's just redefine x for us. So x will now become X and iLock obviously, and all rows, and for the columns we'll be having we'll create a list, right? So this is our X, so we'll be having uh, square feet living, city, square feet above, and bathrooms. Okay, so square feet living is index number 2. So we've got 2, we've got index number 8, so 2, and just write 2 over here, 2 comma 8 comma city and bathrooms. So 8 9 10 11 12, 2 comma 12, and what's bathrooms? Bathrooms is 1, right? And then let's just print x. Okay, so square foot living, square foot above, city, and bathroom. They are the only four that matter to us. Obviously, if you want to make it more, more accurate, what you could do is you could take the cutoff at 0.05, and you could also include bedrooms, floors, square plot, and year built. All right, and that could make the house price more predictable, the model more accurate, more efficient. It depends on you. So that's feature selection for us. And now we move on to regression. For regression also we'll be using the same data set. So this helped us a lot. We won't need to do the pre-processing again. When we are looking at regression, we're going to use the same house price example for it. Thanks for watching, guys. Leave a like if you enjoyed the video. Subscribe for more of such videos. Give me a follow on Twitter at Karia. And if you have any doubts, you can leave them in the comment section below, or you can send me an email at ask.kevinpgaria@gmail.com.